Welcome to my talk. Sorry about my face. I'm not frustrated or angry at you. It's just reacting to the sunlight getting into my eyes. We are going to talk about rethinking browser automation today, unleashing the power of Puppeteer and Playwright with the help of minions. Why minions? Because I see them as little workers which can help us automate our little workflows. A little introduction about myself. I'm a Web Technologies GDE. I work as an independent contractor in the Netherlands with a fantastic client, Jumbo at the moment. I'm the maker of an open source library called Progressive Web App Asset Generator. And I like to share knowledge around JavaScript, TypeScript, Progressive Web Apps, and entrepreneurship on LinkedIn and Twitter. So if you like to connect, you can reach out to me on both platforms. So Chrome is the most used browser in the world. It uses the Blink rendering engine and the V8, which is Google Chrome's open source high performance JavaScript and WebAssembly engine. It's written in C++ and it's using Chrome and in Node.js, among other things. And Chrome ships in three shapes. Chrome stable as we know it, and there's Chromium, the open source project behind the Chrome browser, and Chrome Canary, which is the nightly build for developers. So if you want to test out new browser features with nightly builds, you can get on the bleeding edge of the web with their own slogan and use Chrome Canary. Headless Chrome is the Chrome as you know, without the graphical user interface. Headless Chrome is a powerful toolset for myself as a developer. It makes my life easier. I can use it in my CI workflows. I can automate many things, put it on a server to run it without user interface, and do interesting things with that. So we are going to look at what are those interesting things later on. To launch Chrome in a headless mode, you just need to pass the headless argument, and then it goes headless. Puppeteer is an additional high-level API built upon Chrome DevTools Protocol, and you can install Puppeteer by running npm install Puppeteer. Please do not do that in the conference for the sake of conference Wi-Fi, because it's going to download a really large bundle, a browser bundle with it. It can depend on your operating system and download from 170 megabytes to 280 megabytes. So you can do it at home. And Playwright is a similar library. It came after the Puppeteer. Actually, one of the core maintainers of the Puppeteer left Google and joined Microsoft and started this project. I think the name of the project also tells, Puppeteer, Playwright. And to install Playwright, you can run npm install Playwright, which doesn't install the browser for you, but to install the browser, you need to run npx playwright install. So both libraries, they bundle a browser version to make sure the API version that it provides with the library is compatible with the browser version that's bundled with. Most of the things you can do manually in the browser yourself can be done using Puppeteer or Playwright. Some examples to start with. You can generate screenshots and PDFs of the pages. You can crawl a single-page application and pre-render content. You can automate form submission, UI testing, and keyboard input. And you can capture a timeline trace of your site to help diagnose performance issues. And you can also test Chrome extensions. A basic snippet of Puppeteer looks like this. This is a Node.js code. Puppeteer is a Node library. Playwright is a Node library. You're actually running code on the server. With importing Puppeteer, we call the launch command, and the launch command returns us the browser instance. So it launches the bundled version of the browser. In this case, it is Chromium, because Puppeteer mainly supports Chromium, and it has an experimental support for Firefox. And once you call page.go to, then you navigate to a certain browser page, and then you can take actions on the page, like taking a screenshot of a page. Once you're done, you call browser.close, then it closes your launch browser. As you can see, the APIs are also quite similar. With the Playwright, it's the same thing. The main difference is the WebKit. OK, my pointer doesn't work. But the WebKit that we import with the required statements is one of the browsers you can import. Playwright supports Chrome, WebKit, and also Firefox. And you can take a screenshot on WebKit this time by using Playwright. So this is the Puppeteer.dev, the documentation site of the Puppeteer. If you look at Puppeteer versus Playwright, their documentation and their APIs are also quite similar because the person, one of the persons behind the project was the same person, so it has the same mindset in the background. You have a browser context in this API, and within browser context, you have multiple tabs. Each tab has a page, and a page has a frame. There might be multiple frames depending on iframe you're using, and every frame has at least one execution context. This is how you can isolate some of the browser dynamics using these APIs. And if you want to quickly experiment with the Puppeteer script, you can navigate to this website, chrome.browserless.io, which helps you put small snippets of Puppeteer and experiment with them without running a node server. You just paste your Puppeteer snippet and you're done. In this example, we are actually navigating to the React documentation site and saving the page content as a PDF file. I would like to talk about the DevTools recorder. This is a powerful feature on DevTools. So you can record a certain user behavior of your website. In this example, this is a common e-commerce website where I add items to my cart, and then I do checkout. And I'm recording all these actions right in my DevTools. Once I'm done, I'm going to go and stop the play. Here I see all the actions I took on the page recorded on the DevTools itself. I can expand any of the user actions I took. And when I click Show Code, then I see the code snippets it created for Puppeteer this time. I can also hover over any of the actions, then it shows an automated capability of that certain user action. And once I save this, I can rerun it with Puppeteer anytime. It also applies to Playwright. You can do the same for the Playwright. This is one of the cool things you can do with it. You can automate your user flows. You can automate your testing with it. I'd like to show some other demos related to development workflow. First, I would like to start with emulating the color scheme. I'm a fan of dark mode. All my IDEs are in dark mode. And whenever I develop an app, I also would like to have a dark mode feature on it. And how do you test dark mode feature? You need to take a snapshot of the page and do a visual regression. In this scenario, we are actually calling this emulate media features API of the page, which helps me apply the prefers color scheme media feature. And then I can use with the values light and dark to switch between light and dark theme. And I can take a snapshot of each to later compare with my visual regression tooling. The next one is to demonstrate a side-by-side page load. This is quite useful if you want to compare things with different characteristics. In this scenario, it's a performance benchmark. I'm loading the same application. On the right-hand side is server-side rendered. On the left-hand side, client-side rendered. And the comparison also shows the benchmark with the load times of each approach. And how I do it, in this scenario, I'm using special Chrome launch arguments. So if you take a look on Puppeteer.launch call, there's window size, window position arguments there, which helps me, first of all, run this with headful state. So it's also showing the window, the UI. And then I'm also positioning the windows next to each other. So it also shows some quite possibilities if you want to compare things with your eyes. And then I'm also using something special here, which is the device emulation. So I'm loading iPhone 15 from known devices. So you can load any known device and then let your browser emulate it, like how we emulate mobile devices in our DevTools. It's the same thing. In addition, I'm also customizing the network conditions and also customizing the CPU throttling for this specific use case. The next one is about accessibility tests. Without introducing any dependency in my NPM, I'm actually injecting a script this time, a fantastic library called X for your accessibility tests, and run it against my document model. And it's quite simple. I just navigate to my website, add a script tag with the CDN hosted version of the library. And then this time I'm calling page.evaluate. And this evaluate is a way of creating a portal to the documents of the page. So the page here itself within the Node.js context, but when I run evaluate, it goes into the document context of the web application. And then because of the script tag, I have the X as the global object in my document. Then I can run the whole document model with X. It shows the violations, and my test is checking against the violations named. The next one is about code coverage. I bet you're familiar with unit test coverage tools like Istanbul. It shows like your coverage reports in a nice visual format. But this time, we are using the same visualization for code coverage. Code coverage is something we use for performance optimizations to optimize our bundles. In this case, I'm optimizing my JavaScript bundle. And this report shows me the non-executed blocks in my user journey flow. It's quite handy if you want to code split and optimize your bundle sizes. You can go through a certain user journey in your bundle and then see how much of that bundle you're actually hitting during the execution flow. For that, I'm using page.coverage API. With the page.coverage, I can start collecting JavaScript coverage. And then I do my user flow. I can navigate. I can click on things. I can do so many other user actions. And once I'm done with my user flow, I stop the JavaScript coverage and write this report to Puppeteer to Istanbul package, which shows that visualized screen earlier. Let's talk about Chrome DevTools. It's one of my favorite tools. I use it every day to track memory usage, run audits, emulate devices, throttle network. One of those days, I got curious. My Chrome DevTools was undocked. I am using the shortcut to open the DevTools, actually. When I use the same shortcut on my undock Chrome DevTools, I was able to inspect the inspector, so kind of an inspection. So once I inspected the inspector, I noticed it's just a web app. It's yet another web app running in the browser itself. If you navigate to this repository, you will see the source code of this web app. And then I wondered how it communicates with the browser if it's just a web app. There has to be an API, right? And that is what we call Chrome DevTools Protocol. And Chrome also provides a feature called Protocol Monitor. With the Protocol Monitor, you can actually observe what's going on in this protocol. It's an experimental feature. You need to go through your settings, Chrome DevTools settings, and experiments. Then you need to toggle Protocol Monitor. Once you toggle it, then you jump into the world of Protocol Monitor. It shows us as a tab. And you can start recording protocol calls. Once I record here, I see any action I take on the browser is actually recorded here. Like I navigate between tabs. I navigate between tabs of the browser DevTools. In this case, Performance Monitor just triggered some other call, performance.getMetrics, which shows a lot of interesting values for my performance tests. We are going to see how we can use it in our Puppeteer and Playwright test later on. Chrome DevTools Protocol is what we have been talking about with the Protocol Monitor. And among other things, it also helps you to instrument, debug, and profile Chromium. Once you launch a Chrome instance anywhere, it can be on the server, it can be on your development machine. If you plug in this argument, remote debugging port, you can start debugging your Chrome instance. When I navigate to this port, because I provided this 9222 port, it shows me the already launched pages of my Chrome instance. And once I click one of them, I see a DevTools view right in my browser. Don't be confused. This is not the DevTools view of the Chrome itself. This is DevTools view within the app. So if you open the same page in your Safari, you can actually use Chrome DevTools in Safari. It also provides an API. If I navigate to /JSON and /version, it shows me a lot of useful information like my browser version, protocol version, V8 version, and WebKit version. And there's also an interesting one, WebSocket debugger URL. So this is within this WebSocket URL, we are able to actually instrument the browser itself by connecting over this WebSocket and sending those protocol calls over the WebSocket. This is not a new concept. It was part of Chrome for a long time. And previously, there were other APIs and interfaces for using it. If you want to know more about DevTools Protocol, you can scrape this documentation site. But be warned, this is like low-level browser instrumentation, and you don't have to go there. Puppeteer and Playwright already handles a lot of use cases. But if you got stuck and if you want to go above and beyond in a certain development workflow, you can definitely use it. To experiment with these commands, you can inspect the inspector and then call sendover protocol call to the DevTools itself this time. In this case, I just got like performance.get metrics response. I emulated some device metrics, which changed the viewport of my application. Maybe you notice in the background. Then I'm taking the snapshot, which returns base64 encoded string value of the image. Recently, they published a really nice blog post about it. Also improved the experience on the protocol monitor. So you can navigate to this website to see more about how to use the new version of the protocol monitor. It helps by displaying all the available commands to you. It also shows autocomplete features for the parameters you can use with any command. It's quite useful with this update. But before Puppeteer and Playwright, how did people use these instrumentation? There were so many protocol driver libraries in the past, including with the most popular one, Chrome Remote Interface. To just show you a glimpse of how it was before, to take a single snapshot on the page. It was about 76 lines of code. And with Puppeteer, it's about 5 lines of code. It got that simple. Then the question is, can we use DevTools protocol with Puppeteer scripts? Yes, we can. To use it, we need to interact with create CDP session call. It creates a Chrome DevTools protocol session, opens a WebSocket connection in this case, and then I can listen on command executions or send any commands as I wish. But I was wondering, like, can I, because I don't like downloading 170 megabytes of bundle or like 200 megabytes of bundle to automate a simple development workflow, or like if I want to take a simple snapshot, how I can avoid it. For that, there are core libraries. Core libraries do not ship the browser version. Both Playwright and Puppeteer can be used with this approach. So you can use the light version of the package. But then, if there is no browser, how it's going to execute any of the scripts, right? It needs to connect to the browser instance somewhere. Here, you have two options. You can either use the connect call. With the connect call, you're providing this WebSocket debugger URL that we saw previously in the API response. Or you can provide an executable path. If you know already there is a Chrome version in the system, you can provide it as an executable path and let Puppeteer launch from that executable path. With the Playwright, it's more or less the same. Slight differences in the API calls, but the concept is the same. But then, I don't know the WebSocket URL of a host system. If I'm developing a library and you downloaded my library, I'm sure you have a Chromium version in your system, but I don't know where it is. I don't know the WebSocket URL. How do I get access to it? For that, I use Chrome Launcher. Chrome Launcher is a small library developed by Google. Its sole purpose is to locate a Chrome version in your system. It first looks for Chrome Canary version, or stable version, or Chromium. Then it launches it automatically. Then it provides some useful information. To use it, I call Chrome Launcher.launch with some custom arguments, so I can also control if it's going to be headless or headful, the positions of it, like we did with the Puppeteer. And once it's launched, I get some useful information like the port here. I'm going to use this port later on to get access to it in a different way. This Puppeteer Lite is a term that I coined myself. It's a combination of Puppeteer Core and Chrome Launcher to have like a thin browser instrumentation way. I actually use this method in my open source library. I'm also going to show how it works later on. How they connect with each other. So I import both Chrome Launcher and Puppeteer Core. And then I set my arguments for Chrome. I launch with the Chrome launcher. Then I get the port. And then I'm using that port to interact with the API to get the WebSocket debugger URL. We saw that API previously. Once I get the WebSocket debugger URL, I provide it to Puppeteer Connect call. That's how I can launch a version of Chrome in a host system and then connect with Puppeteer to that launch instance of Chrome. And once I'm done, I disconnect from the browser that kills the Puppeteer instance, and then I use chrome.kill, which kills the launch instance of the Chrome. I would like to show even more demos. This is a live preview of my library. My library is built upon this concept, this Puppeteer Lite concept. How it works, it actually solves a ridiculous problem on Apple devices. If you want to display a launch screen or like a splash screen for your progressive web apps, you need to generate landscape and portrait versions of each device resolution and provide them as like HTML text to your application. And this library first fetches the specs from Apple Human Interface Guidelines, so it's always up to date. And then, based on these device specs, it changes the viewports, takes screenshots, and embeds the HTML code into your web application. A similar concept is used for this Puppeteer example, as I call it. It uses an Instagram-like effects on my images. I remember myself using third-party desktop applications to apply watermark or effects in bulk operations to my images. I can use it with a simple workflow of Puppeteer by using web technologies in my browser. How I do this? This time, I'm not navigating anywhere. I'm triggering browser.new page, and then I'm setting the content on the fly. I'm setting the HTML content on the fly. And then I'm also loading a third-party CSS package that's called CSSgram, which helps me apply the CSS filters. And finally, after getting the image dimensions, I set the viewport, and I get the screenshot with some type and quality parameters this time. And there are also some other things that you can use for monitoring your web application. Let's start with visual regression testing. You can implement your own basic visual regression testing by using Puppeteer. For that, you can get a snapshot of your component or the full page or any block of your web application, and then use it as a reference, and then check against that reference every time you get a snapshot to catch some visual regressions. I'm using this look_same package here, which compares two images and shows me the pixel differences of the images. If it's above some threshold, then I fail the test. Budgets from performance metrics. This is also another useful way of performance testing of your application. You remember the performance.getMetrics protocol call, right? With that protocol call, I get a lot of useful information, and I use it in a different way in my unit test. So I built my own budget JSON, which has my own performance metrics. In this case, for the home page, I'm adding the metrics of number of JavaScript event listeners on the page. It shouldn't be more than 100. And in another, the number of elements I have in my DOM nodes, it shouldn't be more than 2,000, even more than 200, actually. My heap size, memory heap size, shouldn't be more than the budget. By using such a technique, you can introduce your own performance checks in your CI, depending on your performance budgets and performance requirements. And with an abstraction like this code snippet, I'm using this performance enable protocol call and then getting the performance that get metrics, and then comparing it against the thresholds with a simple test suite looking like this. On the next one, I'm comparing the memory leak by heap. For that, I'm again using the Chromium DevTools Protocol. This time, I'm enabling the heap profiler on the web application, and then I start collecting some garbage, get some start metrics, and then I trigger some regression. In this time, it's a scroll gesture. It shouldn't create any memory leak anyways, but think about actions like typical user flows that might potentially create a memory leak, or you want to make sure that it doesn't create any time in the future. Then finally, I collect the garbage with the end metrics. Then I compare them to make sure the heap didn't actually increase more than 10%. Can we run them on the cloud? Yes, we can. I actually ran some of the browser automation tools myself on Google Cloud Functions. In this scenario, I'm showing the example of AWS Lambda. It uses a serverless framework library called serverless Chrome, which downloads and runs the Chrome instance on a serverless function. And it uses the same technique that we used earlier with the Puppeteer Lite approach. So you launch the Chrome in a remote instance, and then you interact with the API to get the WebSocket debugger URL. And finally, you use Puppeteer.connect to connect to that remotely launched instance with your Puppeteer. You execute your Puppeteer script, and finally respond with your API or with your function response. So main takeaways of this talk: Chrome can be instrumented with a WebSocket connection over Chrome DevTools Protocol, no matter where it's launched. And you might not need to download Chrome revision every time. Puppeteer Core or Playwright Core plus Chrome Launcher can do it for you. Headless Chrome can be executed on server environments. Think about cloud, CI pipelines, or on-premise service. You can run it anywhere. You can automate anything you do on your DevTools by using raw protocol of Chrome DevTools Protocol on Puppeteer and Playwright. I hope this talk inspired you to think about your daily workflows, the actions you take, the repetitive actions you take on your browser, on your DevTools, and automate those things to simplify your lives. This is the QR code of all these examples. You can access to this repository, which shows the source code of all the examples that I displayed. And even more, because this is a 25-minute talk, I actually have a lot other interesting scenarios. Please do check out. And with that, thank you for your attention.